Hey everybody, it's Guy McDudefellow, co-chair of the B-Sides Las Vegas Proving Ground track. Our next talk is Analyzing AutoIt Malware, Tools and Techniques by Chris Neal, who was mentored by me, Guy McDudefellow.
Thanks everybody for joining. My name is Chris Neal. I'm a threat researcher at Talos Intelligence, and I've been there a couple years now. And before that, I was a SOC analyst in the financial sector out here in California. And skills-wise, I consider myself a generalist. I have experience with penetration testing, incident response, malware analysis, and just basic reverse engineering. And I have a focus on obscure Windows malware. I like to look at the lesser known stuff because I think it's a little bit more fun than the more popular stuff. And I'll actually be talking about a kind of an obscure malware in this talk actually. So this presentation is called AutoIt Malware Analysis and Introduction. And in this presentation, I'm going to be talking about how to get started with analyzing AutoIt. And this is intended for researchers and analysts who are interested in AutoIt malware but don't have any experience with it. It can be a little difficult to find all the info you need to learn how to do it, so I've put all the basics together in a single presentation, and hopefully by the end of this you'll be able to know everything you need to decompile, de-obfuscate, and analyze most malware written in AutoIt. And so first thing, we need to understand what AutoIt is. And what AutoIt is it's a scripting language written specifically for Windows that's intended for automating administrative tasks, or basically anything a user wants to automate. And it's a lot like Visual Basic in its syntax, and it's fairly easy to write and read, and it's pretty legible as far as scripting languages go. And it can do things like simulate user interaction, like mouse clicks, manipulating windows. And one of its most important functions, especially regarding malware, is its ability to call functions within Windows DLLs, which I'll go over here in a moment. And it's also compatible with the component object model, or COM. And all of these things make it really attractive to malware authors because it provides a ton of functionality with a pretty small amount of code. And there's a ton more functionality than what I've mentioned here, and it's worth looking through the documentation to get a kind of a better idea of what it can do. And so here's an example code snippet from the AutoIt documentation. And it essentially just checks to see if a host can connect to the internet and then returns with either a true or false. And it does this by calling a Windows DLL using the AutoIt function DLL call. And in the orange box, you can see that it directly calls the connect.dll, and then the function is internet connected within that DLL. And so an AutoIt script can be compiled in one of two ways. First is as an A3X file, which requires AutoIt to be installed on the host, or it can be compiled into a standalone executable, which does not require an install. And to create this standalone executable, the script is compiled with AutoIt.exe, which tokenizes the script, then compresses it, and then encrypts it. And this tokenized script is then stored in the resource section of the final executable. And it can also optionally be packed with UPX during compilation, but it's typically not the default setting. And to see this source code after compilation, the binaries have to be decompiled with a decompiler that's specifically made for AutoIt. And speaking of decompilers, these are the two most popular decompilers out there. First being my.auth.exe, and the second being exe2auth, which both have pretty distinct differences. And my favorite by far is my.auth.exe. It's really versatile, and it will decompile almost any malware in my experience. And it'll deal with a lot of obfuscation techniques, which actually can save you quite a bit of time. And it can scan for altered script start addresses, which is a fairly common anti-analysis technique. And it has some really useful log output. In case something goes wrong, you can go through it and try to figure out what's going on. And the second one is exe2auth, which is different than auth.exe, the compiler. It's pretty fast, but at the expense of not being able to handle obfuscation, scanning altered start addresses, and it won't decompile a lot of malware because of that. And another big drawback is that it doesn't handle 64-bit executables, which is not a good thing in 2021. So this is better suited for non-malicious scripts if you just want to look at some sort of boring administration script or something like that. But this typically won't work for malware. So there's some other helpful tools that will make your life a lot easier during analysis. And a big one is the ISN AutoIt Studio, which is a free dedicated AutoIt IDE. And it's got some pretty useful features like debugging, syntax highlighting, and a built-in code reference, which are all really helpful during manual obfuscation because you don't have to keep looking up the documentation and all that stuff. And it also has a dark mode, which won't burn your retinas while you're analyzing these samples, which is pretty nice. And it's also really handy to have just a good old regular text editor, which can it can really be whatever you want. But I definitely recommend using VS Code just because of the AutoIt plugins, and I found that the regex search in it is really helpful. And plus, it's just great to have a code editor in general, like VS Code, especially for Windows. It's got a lot of really useful functions inside of it. And of course, for analysis, we're going to be using a Windows VM, and I use Windows 10 most of the time. And some binary inspection tools like CFF Explorer or PE Studio are good to have, as well as a hex editor occasionally. And last, I use Python for any scripting tasks like writing a de-obfuscator, which I'll be doing here in just a moment. And so now that we've gone over the basics, let's hop into some actual malware analysis. And the sample I'll be walking through today is actually some real-world analysis I did for a blog post for Talos. And a quick note about malware and AutoIt. Tons of malware families have used AutoIt at one time or another, and the families listed here have used it in at least one attack phase during a campaign. And this is a non-exhaustive list. These are just the ones that I thought of when I was trying to make a list. But there's plenty more out there that use AutoIt besides these. So the one we're going to be taking a look at is LodaRat 1.1.1. And Loda is essentially your typical rat that does things like steal browser cookies, cache passwords, all that good stuff. It's not always obfuscated, but for this example, I chose one that is. And originally it was discovered in 2017, and it's been active ever since. It's, in my experience, it's getting a little bit more common as time goes on. I've been tracking it for a little over a year now, and I actually published a series of blogs on the Talos website if you want to go check those out, if you want to know more stuff about Loda after this. So on to analysis. The first thing we want to do is pop our sample into a binary inspection tool. Like this one, for example, is PE Studio. And this is the easiest way to tell if you're dealing with a compiled AutoIt script. And here in the orange box, you can see that the version info metadata states that the version of AutoIt, which in this case is version 3. And then, of course, it's always good to have the SHA-256 hash of the malware sample as well. So the next thing we want to do is try to decompile the script. And we're going to be doing this in our analysis VM. And I always start off with my AutoIt.exe first because I usually have to switch to it anyways if I use anything else. And once the decompilation finishes, the script will appear in the top section. And we won't be using this interface to do any analysis though. My AutoIt.exe will actually create files containing these scripts. So we're going to be using those in a different program after this. And at the bottom, you have these output logs. When something goes wrong, these can be really helpful to figure out what was going on. And then, so speaking of things that can go wrong, what can go wrong when you're analyzing this stuff? One of the most common roadblocks is the script not decompiling, especially with exe to aut, which is why I always start out with my aut.exe instead. And not decompiling can be caused by a couple things. Either the script start address has been tampered with, which is pretty common, or the decompiler was tricked into decompiling a decoy script. And this technique is outside of the scope of this talk, but there's a great post about it by Unit 42, which I'll be giving a link to at the end of the presentation. And then another roadblock you'll run into is obfuscation, and it's very likely that if you're dealing with malicious AutoIt scripts, it will be obfuscated, which is, well, we'll be discussing that here shortly. And the last thing, another reason not to use exe to aut with malware is that it actually may execute the script. And the Unit 42 post I just mentioned talks about that, so it's definitely worth a read to understand how that works. Okay, so let's say you got over those roadblocks and you successfully decompiled the script. If it's obfuscated, it's going to look a lot like this jumbled mess, and this giant blob of encoded strings will eventually be decoded when the malware runs. It looks worse than it really is, and eventually we're going to be able to make sense of all this junk. And so in most cases, the two types of obfuscation that you're going to see in AutoIt malware is string and execution flow based. And with execution flow obfuscation, the author will try to make the script really hard to follow by adding unnecessary or overly verbose functions or a ton of nested functions or anything that makes it really hard to follow what's going on. And with string obfuscation, there's going to be a routine or multiple routines that will decode the encoded strings in real time during execution. And typically it will be similar to something like this. This is a loader-rat decoding function shown here, and it's usually found at the end of the script in most cases. It's important to note that in AutoIt, there's only a few different obfuscation choices that a malware author can use purely because of the way AutoIt works and the way that the programming language operates. And so our first step with dealing with this kind of obfuscation is to figure out how this function works. So the decoding routine will be called hundreds and hundreds of times in this script. So we need to figure out what this routine is doing each time it gets called so we can implement it ourselves and then write our own decoder. And this particular function takes two arguments. The first is the encoded string, and the second is a static key of sorts. And in loader-rat's case, this key is stored as a global variable. So our goal is to make this decoding routine more readable so we can figure out the logic and write our own decoder. And the best way to get this done is by replacing all the junk variable names with meaningful ones. And we can also do things to simplify it, like putting that static key that's stored as a global variable and put it directly in the routine so it's a little bit easier to read. And the code shown here is actually the same routine I showed on the last slide, but cleaned up. And you can tell that it's just a lot easier to read and a lot easier to figure out the logic behind it. And so now that we can read the code, we can translate it into Python. And here I have implemented the exact same logic into a function I've named decode. And as you can see, it's actually pretty simple once it's not so ugly. And I've chosen a random string from the malware script and then stored it as a test variable while writing this. And it's a lot easier to do this than to test the script on an entire file. It goes by a lot faster. And once I've got the decoding logic worked out, I can just run the script and then see if the output is readable. And in this case, I've got it to work. And then once I run it, I can see that that string equals encrypted password. And so now that we've implemented the code, the decoding properly, we can extend that script to find and decode each instance of the decoding routine being called in the malware. And I find that the quickest way to do this is to use regex to find each function call and then send the first argument to my Python decode function. And in this script, I have the results print to standard output, but this can be easily extended to find and replace each instance within the malware itself, and then just decoding the script that way. But you can also just run the script and then have everything go to standard output. And you can see here that just running my script gives me a pretty good idea of what the malware is doing. Here in the orange boxes, you can see it's doing things like targeting Chrome, Opera, FileZilla, and is likely making multiple registry changes. And so there is a lazy way to deobfuscate this, but I don't recommend doing this if you feel that you shouldn't be running the malware, because you do have to execute it. And so you want to make sure if you're doing this, you're going to disconnect the VM from the internet. And the way this works is that we're going to be removing any calls to the sleep function and then run the script in ISN Studio with some minor modifications to the decoding routine. And so what we're going to do is add 2 calls to create text files and then output some data to those text files. We need to add 2 lines of code to the function in specific places and then execute it. First, we need a file write function that outputs the current encoded string and a carriage return into a file. And then second, we have another file write call that writes the decoded string and then a carriage return to a second file. And this gives us 2 files where an encoded string can be paired with a decoded string by the line number in the text file. And sometimes this method is, you can save you some time, but most of the time it's worth writing your own decoder because this method is pretty messy, and sometimes it's a little too crude to get things done. And now that we can read the malicious script, what should we look for? I'll redo this slide, hold on. Now that we can read the malicious script, what should we be looking for? One of the easiest things to spot are the AutoIt macros, which begin with an @ symbol. And these won't be obfuscated since they won't work if there's any sort of string manipulation, so they're pretty easy to find. And these are typically used during system enumeration, and the names are pretty much self-explanatory, like OS version or desktop height. These are used pretty frequently to just gather some quick information and then send it back to C2. And so here's a non-exhaustive list of functions to keep an eye out for. And as with macros, the function names themselves are fairly self-explanatory. What you want to look for here is any interaction with DLLs, the registry, system files, or any apparent network functionality. But the function I do want to point out here is obj get or object get. And this can actually lead to some pretty interesting finds while you're looking through the code, because this is how AutoIt interacts with the component object model, or COM. So always keep an eye out for this, because you'll definitely find something interesting once you find one of these. And so last couple things is that AutoIt malware will commonly store binaries as strings, like the one shown here. And this is a sample of LoaderRat that had a proxy client stored as an unobfuscated string that would later be converted to a DLL using the binary to string function. And then that DLL could be used in C2 communications. And binaries stored as strings may or may not be obfuscated, just depending on the author's choice. And so here we have one last example of a binary being stored as a string. And this is from the same Lotus sample as the last slide. This instance is pretty interesting because this is actually just a SQLite library, which is used for the sole purpose of making a single WMI query via the AutoIt COM interface. And this query enumerates any antivirus products installed on the infected host, and then later on in the script, LoaderRat will actually attempt to kill any processes that belong to those antivirus products. And then before I go, I just want to give you guys a few more things you can take with you. And one of the most important things to do if you want to learn more about this is go out and find some samples on VirusTotal and just explore the tools that I mentioned. That's the best way to learn this stuff. It's also really helpful to go out and read the AutoIt docs in forums. One thing you don't want to do is don't talk about malware or decompiling in the official AutoIt forums, because they will ban you immediately. So another helpful thing is to go look through the decompiler source on GitHub. Go find the AutoIt stuff, and it's all open source, and it can be pretty helpful to understand how this stuff is compiled and decompiled. And there's a ton of good blog posts out there that have a lot more information. And the one I would like to point out was the Unit 42 blog on those decoy scripts. Just look up Unit 42 AutoIt, and it'll be one of the first things you get. And then I did write a series on LoaderRat that I've been following for a year or so. And go look those up if you want to learn more about LoaderRat. They're pretty interesting, I think, and hope you guys enjoyed the talk.
Excellent. Well, that was great. So I guess what we want to start off with is one of the questions from the channel, or from the Discord channel. Cool Acids asks, how often do you come across benign samples, and what's the weirdest sample you've come across, either malicious or benign?
Sure. Yeah, I actually I look a lot through like VirusTotal and malware repositories like that. So most of what I find is malicious. I don't see a whole lot of benign things getting uploaded to VirusTotal, but not that it doesn't happen. I have run into them. I've seen some pretty weird malware that just looks for some pretty strange stuff, like very specific things with sometimes like specific games. It'll look for game files for very like unusual games that most people haven't heard of, almost like Candy Crush games, kind of like that, where they just look for any sort of save files and stuff like that, and then send it back to C2, and that's literally all it does. Sure. So there's weird stuff out there like that, and then there's a lot of other stuff that is quite quite dangerous, where they are looking for any sort of banking information, credit card information, social security numbers, stealing credentials and whatever they can. So it kind of runs the whole gamut, where there's benign things all the way to very malicious, just depending on where you're looking.
Okay. What about breakdown of 32-bit versus 64-bit?
Sure. Yeah.
Go ahead.
So I believe it's AutoIt to exe, or exe to auth. The decompiler I was talking about that actually doesn't really handle malware very well. It does not work on 64-bit binaries. So sometimes you need to convert 64-bit to 32-bit so you can use that decompiler. And there's a great blog by Hexacorn. I'll put the link in the Discord so everybody can check it out. That goes over how to do that. It's actually pretty interesting because you just run essentially a script that runs through and changes some bytes here and there, and that's literally it. There's not a whole lot of difference between 64 and 32-bit between them for AutoIt. It's very close. So sometimes you may need to do that. I haven't run into it too many times, but it's definitely a thing that you might run into. So I'll be posting the blog here in a sec.
Sure, no worries. Now, I know AutoIt's been around for quite a while, and it predates PowerShell. How widely is it still used versus PowerShell? I mean, PowerShell has some advantages versus AutoIt. So, how often do you still see it used in the wild?
Quite a bit. If you go on, let's say you just go on VirusTotal or something, and you just do, a string search for AutoIt version 3.3 or whatever version, you're going to find like thousands and thousands of samples, and a lot of them are going to be malicious. And there's new ones popping up every day. Like Loda, the one I was just talking about, I've been tracking that for over a year now, and it's gotten a lot of traction in the last, I would say, year. It's still just as common as it was when people first started abusing it, and in some respects, it's more common with stealers and stuff like that. And so I think the reason it's becoming more popular, it has become more popular, is that it's really easy to code. When you're reading the code, it's super easy to understand. You don't have to understand a lot about, programming paradigms and stuff like that, and how to interact properly with, the Windows API and stuff like that. And it's so easy to, interact with things like COM and, some of the more complex APIs with Windows. It's ridiculously easy in AutoIt. So it's a shortcut of sorts. It's not nearly as hard to program, and it's really powerful for what it is.
Okay. Why do you... So with PowerShell becoming more integrated into Windows, I think there's no longer any aspect of Windows system administration that can't be done with PowerShell. Do you see any shortcomings with AutoIt versus PowerShell?
Yeah, I think that for one, to me, the binaries are huge. If you do the standalone binaries, they're like 20 megs or something like that, because it includes like so many different libraries and things like that. And it can be a 1,000 line script, and you have like a multi-megabyte file. And if you don't want those big files, then you have to have AutoIT installed on the endpoint or whatever system you're using. So it's kind of harder to use. It's not native, so it's not as clean to use AutoIT on like across an entire network or anything like that. And like PowerShell's integrated, so it makes more sense for PowerShell for like large administrative tasks on like a corporate network or anything like that. And kind of going back to, it's easier to program. AutoIT is easier to program in. So I think that's the main reason why, people are using that instead of PowerShell, just because it's not as complicated looking as PowerShell. I really think that's it.
Yeah, I mean, it really reminds me a lot of Visual Basic in some ways. Oh
yeah, absolutely. Sometimes when I see some AutoIt code, I think I'm looking at Visual Basic, but I'm I'm not. Sure. A lot of similarities, like syntax wise.
Okay. What about server versus workstation? Do you see any malware that's targeting specific types of installations?
I have not run across that. To me, the areas I see AutoIt used in a lot are just kind of like, spray and pray malware. Just send out a bunch of instances of this malware and hope somebody clicks and somebody, gets it to run on their system. And then hopefully you'll get something out of it. I don't think I've ever seen something that was really targeted towards specific, operating systems or, more kind of advanced tactics. It's all very basic, but it doesn't make it any less malicious or dangerous.
Sure. So nothing specifically targeting like AD or, member servers or additional domain controllers or stuff like that.
Yeah, not that not in the research I've done, I have not run across that, but I would not be surprised if there's been someone out there that has done that, because AutoIt's totally capable of doing those things. As for interacting with Active Directory, I don't know if that's like native to AutoIt, but I'm sure it could do that no problem.
Right. Well, it's not necessarily native to PowerShell either. You have to have those modules installed in order to interact with Active Directory.
True. Yeah. So yeah, I mean, theoretically, I don't see why that couldn't happen. So, I mean, that is probably a pretty good avenue to do some extra research in. Sure.
Are there any other types of frameworks or languages like AutoIt available for the sort of system administration, or this is pretty much it?
It's the only one that I know of. It's kind of in this family, where, it's not just a scripting language. It's kind of like to me, it's kind of an in-between between like a compiled language and then like a, scripting language, where you can have like a standard, compiled binary, or you can just run a script if you want to install the library and the, AutoIT on a client or something like that. I don't know of any other that are languages that are like Windows specific like AutoIt, but I'm sure if someone took the time, they could make Python to be kind of similar. But I think that'd be quite a task to compete with AutoIt.
Sure. What about comparing this to something like Ansible or Chef, where you're doing deployment work and you're installing things at a target, but you're making sure that you're this whole idea of only changing the state once. Is that something that AutoIt supports, or is that more of a configuration management paradigm?
Yeah, I don't think AutoIt supports that like as it is. I know a lot of it is just for automating like tedious stuff, like if you need to go through and just like change some settings or something on an endpoint, you can push it out through whatever an admin uses to push stuff out. So I don't think it goes quite that far, but yeah, I'm sure someone could also implement that as well, because AutoIt from what I've seen and what I've done some research on it, it's really versatile and it's really powerful for being such a simple language. Okay. All right. So we've got about 2 minutes left. Cool. I'm looking to see if there's any questions left in the channel. Is there anything that you didn't have time to add that you'd want to touch on now? Let's see. I think the main thing with the hexacorn blog I was talking about, because that's one thing you might run into. And one thing I would like to touch on just real quick is that one of the hardest things about researching AutoIt is understanding how like the compiler actually compiles AutoIt and like tokenizes the script and then compresses it and then stores it in the resource section. That's all closed source. So if you do want to get involved in that, it's a bit harder, actually quite a bit harder than just learning how to decompile and stuff like that. So that's one thing I'm personally going to start looking into, because it's not a common thing to know a lot about. So I think if you do want to get into that, the best way to do that is start looking at the decompiler GitHubs, going through the source code and then just seeing what they're doing. And because they've gone through and done all the work of understanding it. So I think it's the best way to understand it if that's what you want to do. Sure. Okay. Well, excellent. Well, thank you so much. And this has been a great talk. I learned a lot. Thanks. And yeah, thank you very much. Right. Thanks for having me.